Good morning, guys. So today what we are actually moving into is our last chapter for pre-calculus, which is 11.1, Finding Limits Using Tables and Graphs. So chapter 11 in your book is all about finding limits, and it's the last chapter in most pre-calculus, but it's actually the beginning of calculus, and you'll probably talk about it at the beginning of next year if you are learning calculus, but limits are not as bad as people make them out to be. So let's get into just a few basic examples to get us started on limits and an easy way and a go-to way to always find a limit. So the notation for a limit, and of course you can see this a little bit differently, is the limit as x approaches c of f of x is equal to n. So it's read as the limit of f of x as x approaches c is n, exactly how I just said it. Now you always see it written in a similar way. Of course, f of x is usually replaced with some sort of function like x squared or, polynomial x squared plus 3x. X approaches c, so the x and the arrow is always there, but the c and the n are different numbers. So c and n are just numbers. And important to note, it says x approaches c, so c is an x value, and it cut off. So I'll just leave it, c is an x value, and n is a y value. Okay? So those are the two things. So it says as x approaches a certain y value, where is y going to? And that's all about a limit, what it is saying. It's saying what is the function doing as we're looking at a certain x value, what's happening at that y value, or as we approach that value. One thing that is misconstrued with limits, people often believe that c has to be infinity, so there has to be a little infinity down here. That is not true. It can be infinity, but it can be a number. And n is the same way. It can be infinity, it can be a number, and it also, there is possible that a limit cannot exist, which some of you know from a popular movie that you grew up with. So let's just get into some notes on actually finding a limit. If we look, our first example says we are finding the limit as x approaches 3, so as x approaches 3, of 5x squared. So I'm just going to write that a little bit bigger. The limit as x approaches 3 of 5x squared. So if you notice, there is no equals here. That's the part you're trying to find. When you're finding a limit, you're trying to see what is it equal to. What is the limit as x approaches 3 for that function? So an easy way to find a limit is we can use a table. So how are we going to use this table? Well, I have a note on the right side, and this note is just a go-to, and you can look at the worked out notes for this section. You'll see these little notes on the side. Simply, what are you going to do? In this case, you're going to choose numbers to the left of 3 and to the right of 3. And I'm going to set up two different tables so we can figure this out. So why 3? So we are finding the limit of the function 5x squared as x is approaching 3. So as our x value gets closer and closer to 3. So why are we going to pick values to the left and right of 3? Well, we're going to pick values as we're getting closer to 3. So 2.9, 2.99, 2.999. We're going to pick values to the right of 3. 3.1, 3.01, 3.001. We want to figure out what's happening at 3. So we're going to get closer and closer and closer and plug in values that are closer to 3. So we have our x and y. I'm going to separate them in two separate tables, values to the left of 3. So what are some values to the left of 3? 2.5, 2.9. Remember, where x is approaching 3, we're getting closer and closer to 3. So I'm going to pick values that are closer and closer to 3. And now what I'm going to do is I'm going to simply plug them into the function. F of x is our function, that's 5x squared. So I'm going to plug these values into 5x squared. So 2.5 is going into 5x squared, so 5 times 2.5 squared. is going to give me 31.25. I recommend using an actual calculator here. You can find one online. 5 times 2.9, quantity squared. Make sure you use parentheses around the 2.9 and squared. 42.05. 2.99, plug it in. 5 times 2.99 squared. 44.701. 2.999 squared times 5. 44.97. Okay? Now don't do anything yet. Don't look at it yet. Let's talk about, we're going to pick values to the right of 3. You're always going to pick values to the left and right of whatever x is approaching, because we're picking x values. So, I'll start with 3.1, but then I want to get closer and closer to 3. 3.01, 3.001. I could have picked 3.5 and then 3.1 if you want an extra value. Usually 3 to the left and 3 to the right are more than enough. So 3.1 squared times 5, plug it in. I'm going to get 48. 3.01 squared times 5, 45.3. 3.001 squared times 5, 45.03. Now we're going to look at it. It says, if you look at my note on the right, the number that the answers get very close to is the answer. So let's look, the closer and closer we get to 3, so 2.99, we're at 44.97. The closer and closer we get to 3, 3.001 is pretty close to 3, we get 45.03. What value do you think we're getting closer and closer to as we get closer and closer to 3? And I think a lot of you would say that value would be 45. So, the limit as x approaches 3 of 5x squared is equal to 45. What's another way that we can do this? Well, let's try to plug 3 in. 5 times 3 squared. 3 squared is 9. 5 times 9 is 45. So in this case, sometimes, and we'll talk about when this case is, sometimes when we have a polynomial, when we have a function, we can just plug the x value straight into the function in the limit, and we will get an answer. Okay? Okay. But you can always use a table to help you. You're going to look at the x value you're approaching and get closer and closer to that value. Let's look at a second example again, just to get used to it. So if we look, we have the limit of 3x squared plus 4x as x approaches negative 2. And I'm just going to write this a little bigger as limit of 3x squared plus 4x as x approaches negative 2 for this function. What is this limit equal to? Remember, we're looking for a y value. So what I'm going to do is I'm going to make two tables. But remember, you are getting closer and closer to the x value of negative 2. So I'm going to pick values really close from the left of negative 2 and from the right. So what's really close to negative 2? From the left, negative 2.01, negative 2.001. Please do not just pick one value. You have to do at least two, to the left and to the right. From the right, what values are really close? Negative 1.99, negative 1.999. Okay? So we want to see what happens as we get closer and closer to negative 2. If I'm going to plug this in, and be careful when you're plugging this in. When you're plugging in something like negative 2.01, you want to make sure you're going to have 3 times, in parentheses, negative 2.01 squared plus 4 times negative 2.01. Make sure you use parentheses. That's going to give me 3.92. Do the same thing for negative 2.001. 3.99. Okay? Now let's look at the values to the right. Negative 1.99 squared times 3 plus 4 times negative 1.99 is going to give me 4.08. And then we're going to get a little closer to negative 2 with negative 1.999. Oh, I switched up my values. Sorry guys, let's backtrack 1 second. So if I do these I'm just going to switch up. I have my x value switched. Sorry guys, so if I plug in negative 2.01, I'll get 4.08 over here. And then if I plug in negative 2.001, I'll get 4.008. If I plug in negative 1.99, I'll get 3.92. And then I'll get 3.99. I apologize for the switch. So plug these in. Make sure you have the right ones on my end. Just a few errors going on there. Okay. So what I did was I created two different tables. Two values to the left of negative 2, two values to the right of negative 2. So you can see those two different tables. I plugged them into my function. My function is 3x squared plus 4x. And I'm going to look at the two values that are closest to negative 2. So the two y values that are closest to negative 2, in this case, the x values, are y values of 4.008 and 3.99. So what y value do you think you guys are getting really, really close to with those two values? And I think you guys can all say that that will be a value of 4. Let's check and see if our plug-in method works out here. So if we look, our plug-in method, that if we plug it in, let's plug in negative 2. 3 times negative 2 squared plus 4 times negative 2. What we would get here is negative 2 squared, 4. So get 3 times 4 plus negative 8. 12 minus 8 is going to give us. So the limit, as x approaches negative 2, of 3x squared plus 4x is equal to 4. Okay? And let's just sum this all up, because those are the only two examples. The last slide simply says, what do these examples imply? So when you are dealing with a limit, if the function is a polynomial, so if f of x is a polynomial, like the last two we dealt with, 5x squared, 3x squared plus 4x, x cubed plus 2x. If the function is a polynomial, you can simply plug in the number x is approaching and that value c, remember x approaches c, to find your y value. So for both of those examples, we simply could have just plugged in our c value into our function. So for the first one, we could have plugged in, I believe it was 3. For our next one, we could have plugged in negative 2, and that would have given us our answer. The other moral for all of this is that if all else fails, you can always use a table. So I think a few of the ones I gave you on your homework are not polynomials, so you would have to use a table. So all else fails, use a table. And I really want you guys to use a table. You're going to have a lesson check for today. I want you to use a table and double check your answer by plugging in if possible. But all else fails, use a table. If it's a polynomial, you can check yourself and plug in. If you're getting crazy values in your table, I would really make sure right now, for tonight or tomorrow when you practice, I'm only giving you nice values that will work. So if you're getting crazy numbers, watch your parentheses. Be careful how you're plugging into your calculator. Okay? Sorry about the few typos in there. Keep up the good work, guys. Make sure you're watching these videos, especially those of you that are going to calculus next year, because they will help you. You will see this in the beginning of the year. Okay? Good job, and I'll see you at your next lesson.